Today answering subscriber questions on the Gigabyte Z590 Vision D motherboard. Let's take a look. And the question we're going to address on that particular video came from MMA. And he asked, "Hi, great video. I'm looking at upgrading my PC and considering the Gigabyte Z590. However, not sure which one. I have the Gigabyte RTX 3060 GPU and wondering which Z590 Vision or just maybe another board would be a good match. I use Revit and rendering software." Okay, my response. Welcome, thank you, appreciate your comments, great question. According to PC Part Picker build list, there are 65 Z590 motherboards, 15 of which are Gigabyte. And we're going to go to that list in just a minute. We chose the Gigabyte Z590 Vision D Thunderbolt 4 due to the fact that at the time, the only way to get Thunderbolt 4 was built onto the motherboard. We now have access to the Thunderbolt 4 add-in card, and that makes a big difference if Thunderbolt 4 is important. I think it will be to you. For starters, list your top 5 priorities in order of preferences. For our choice, number 1, Thunderbolt 4. Number 2, 8 cores with video for an entry-level build. Now we spec'd out a 10-core CPU, but that is only PCI Express 3. If you want PCI Express 4, which you would for the M.2 NVMe drive, then you're looking at 8 cores. Okay. If you want more CPU cores, have you considered either an Intel Z690 or an AMD X570? Now I'm going to interject. Because of Thunderbolt 4, then we would probably be looking at an AMD B550. And we have a video up on the Asus ProArt B550. But for this particular situation, we're looking at Vision. And our greatest concern is the CPU core count. So on any of these that I have outlined, we're looking at 16 cores, more processing power. You may decide to upgrade your GPU later for the same reason. Now, I recommended at that time, and we may get into that in another video, the Gigabyte Z690 Aorus Pro. 16 cores, Z690 chipset. It's the Gigabyte Z690 Aorus Pro that has a balance of value in price and performance of features. Has Thunderbolt 4 support for the Thunderbolt 4 add-in card. Motherboard will support 128 gigs of RAM, suggests 64. We're going to get more into this in just a minute. Okay, in Revit, you want to be sure and turn on hardware acceleration to utilize your RTX 3060 GPU, which has 12 gigs of video RAM. And of course, my personal preference is AMD. And we may follow up with this with a video to help as many subscribers as possible. Hope that helps. Stay tuned. And that's where we're at right now. Okay, as always, change one thing changes everything. So the primary requirement on this is going to be Revit. So what I have is I have a list, and I'll have this in the description because I don't want to go through all that. It takes a lot of time, but I'm going to kind of give you the synopsis of this so we can keep it short. If we're looking at Revit and that type of rendering software, which is from Autodesk, some of the specs they get into are kind of interesting and fascinating. It's more not just what they do say, but what they don't say. But I want to take a look at those Revit specs. We're going to also get into PC Part Picker because we need to look at the what, why, and how of how this is going to go. So the title of this video is going to be the Gigabyte Z590 Vision, of which there are 3. Let's take a look. Let's go to PC Part Picker, the System Builder list. First thing we want to do, we're going to choose a motherboard. And we're going to choose a motherboard based on the chipset. Show more. I did a search on the document for the Z590. I'm going to select that. We'll go to the top. And to reiterate, that gives us a list of 65 products. Now we're going to do a sub-search based on the brand preference that you mentioned, just as the video, Gigabyte. And that's going to give us another search of 15 compatible products. I'm now going to do a search on the document for the word Vision. And I'm going to find 3. So I'm going to select and check those 3 boards, number 1, number 2, and number 3. And now back up at the top where I can do a comparison of the selected items, I'll say let's compare. And we have 3 motherboards. All right, the easiest comparison right off the bat is on the far right. That's Mini ITX. If Mini ITX is what you need, then that's where you'll stop. If you don't need Mini ITX, let's look on down at the differences. Okay, across the board. The Mini ITX system, 64 gigs, it only has 2 memory slots. So my concern, even if I'm going to say and recommend, say, 64 gigs, the company with Revit, say they recommend 32 gigs. Okay, I want room to upgrade. I want room to be able to grow. So if the board only allows me 64 gigs, that limits my upgrade potential. But let's keep going, go a little further. And the other key items, I won't look at the third one. Let's look at the 1 and 2 option. The biggest differences we're going to have on the M.2 slots and on the PCI Express slots. For example, we have right here a PCI Express by one slot on one of the boards. Whether that matters or not, no big deal. Where it really matters, and it is more of a big deal, is when we get to the M.2 slots. Now, one board will support, and this is a key point, will support 4 M.2 connectors, whereas the other board only supports 3. But when you get down to it, and we're going to get into the nitty-gritty, because once we go to the manufacturer's website, we'll take a look at the motherboard, we're going to download the manual, we'll get into the nitty-gritty, because there's 3 things we want to look at. I want to see the diagram, if we've got one. I want to see the motherboard layout, which we'll have, and I want to see the specifications for that board on how that lays out. So let's get back to this. And of course the other issue is going to be the Ethernet. 1 2.5 gigabit Ethernet and 2 2.5 gigabit Ethernet. And the Wi-Fi. One of them has Wi-Fi 6. Okay, the board we recommended at that time that had everything because it was built onto the motherboard because of Thunderbolt 4 was the Gigabyte Z590 Vision D, $370. Let's zoom back in on that. And $370 versus the one we're getting ready to look at now, which is $250. And for those that want to stop at that point, for $250, I think that'll do what you need. Now, you're going to be missing a couple of features. You don't have Thunderbolt 4 built onto the board. You can add it. I think you're going to want it, but you don't have to have it right away. 2, the issue with Wi-Fi. Because of DPC latency, that'd be the first thing you turn off. Now, for those that are doing audio rendering, DPC latency is a big issue. For those that are doing video rendering, you may never experience it. But I'll just say Windows is not a real-time operating system, and because of DPC latency, that's one of the first things you turn off is Wi-Fi. So not having Wi-Fi on the board, I don't think Wi-Fi should be on the motherboard. Wi-Fi belongs on laptops, but that's just me. I like a hardwired connection. So let's get back to this one. So that you can save some money on that particular board, let's go look at it. I'm going to highlight that description. Let's go out and do a search. Okay, we'll find the Z590 Vision G, good looking board, Gigabyte Creator motherboard, kind of like the counterpart to Asus's ProArt Creator motherboards. Let's look at specifications before we go to the manual. And we want to look down here at expansion slots, storage interface, and we want to download the manual. So we'll go to Support, Manual. And of the 3 manuals, we've got a Unique Features Introduction, a RAID Setup Guide. What we want is the primary manual. So we're going to download that. And I've taken the liberty of already downloading it. And what I want to do a search on the page for, I want to see the layout. Now, we're going to look at 3 pages. The motherboard layout, the block diagram, and then we're going to look at product specifications. So page 4, 5, and 7. Let's go to the motherboard layout. I like to see what's what and where's where. Okay, we have 1, 2, 3 PCI Express by 16 connectors mechanically. Electrically, we have PCI Express by 16, and then we have PCI Express, and if you'll notice here, we can see the fine print, PCI Express by 4_1, PCI Express by 4_2. That means each one of those slots is 4 lanes wide, and that's 4 lanes electrically. That's important because one of those slots, and I'm not sure which one, could be the first one, could be the second. We'll have to double check. You'd have to check that when you install it because Thunderbolt's a little funny about that. But one of those is adequate for Thunderbolt 4 because Thunderbolt, whether it's Thunderbolt 3 or Thunderbolt 4, only uses 4 PCI Express lanes. Either way. But what's specific about Thunderbolt 4, it is vendor specific, and Gigabyte is using a 5-pin and a 3-pin header, whereas Asus, I believe, is 14-1 pin, and MSI has a different header. I believe it's 16-1 pin, and MSI is going to have Thunderbolt 4 support, but MSI does not even have a Thunderbolt 4 add-in card listed or anything about it yet. So in time. It's kind of like the some of the stuff on the Z690 that we're going to be talking about. Some of it's a little premature, but we need to talk about it because, man, that's a can of worms. So on this board, let's look now at the M.2 connectors. And we have, up here at the top, M2A_CPU, M2B_CPU, and M2C_CPU. And then the last one is M2P_SB. I guess they use the SB designation for Southbridge, another term for a PCH, Platform Controller Hub Chipset. I guess it's an easy way to do an acronym. Anyway, what's important are how many lanes we have access to. And because we've got probably 20 lanes, right there 16, there's 4, that's 20. So if you give me these two, I think the explanation is going to be self-evident when we look at the diagram. And I love these motherboard block diagrams. Vendors, a lot of them don't put this in like they used to, and I think it's an obfuscation because they don't want you to know you can't do everything at once. You can do a lot of stuff because they're shared resources, you just can't do everything at once. For example, here's the CPU. We have the PCI Express 4.0 bus if we're using an 8-core CPU. And again, to reiterate, if we go to a 10-core CPU, then we're using PCI Express 3. Okay, we have one dedicated M2A_CPU socket, dedicated. What I don't like is if you'll notice here we have one PCI Express with 16 slot, it's on a switch because it shares resources, it shares bandwidth, it shares PCI Express lanes with M2C and M2B_CPU, which means 4 lanes, that's 8, which means PCI Express by 16 mechanically becomes PCI Express by 8 electrically if you use all those resources. And then of course through the chipset we can scroll on down and we have the M2P_SB and everything else through the chipset. And then through the PCI Express 3.0 bus we have two 4-lane slots. And again, to reiterate, one of those can be used for the Thunderbolt add-in card, which you can add later. Okay, let's look back up here at the top, how all that works out. Let's go look at the specifications now. All right, we're now on page 7, and we're going to scroll down. This will probably take us on to page 8, and we are looking for expansion slots. One PCI Express by 16 slot running at by 16 electrically. For optimum performance, if only the graphics card is going to be installed, be sure to input that in the PCI Express by 16 slot. Yeah, no kidding. Okay, here's the kicker. The PCI Express by 16 slot shares bandwidth with M2B and M2C_CPU connectors. The PCI Express by 16 slot operates at 8x mode, which is 8 lanes electrically, with the device installed in M2B, to reiterate, or M2C, because each of those requires 4 lanes. Okay, that's what you get with a shared resource. So the next question that comes up is, okay, how does all this play out? Okay, a lot of things to keep in mind. For those that want to use an external GPU, they put that, like you've got an RTX 3060, RTX whatever, in an external GPU, that's going to be on 4 lanes. So if you use all 3 of those connectors, your GPU right now internally would be on 8 CPU lanes. If you plugged it in for whatever reason to an external GPU, you'd be using 4 lanes through Thunderbolt. So you're ahead. I would rather have it on 16 lanes, but if you choose to do that, you can. Now, the next question that comes up, what about RAID? Okay, RAID is supported. Let's see what that says, because this is Intel RAID. Okay, support for RAID 0, 1, 5, and RAID 1.0. And then we need to refer to internal connectors for the installation notices for M.2 and SATA. And the next question that comes up, can you have an M.2 NVMe RAID and a SATA RAID? Yes, if you have the connectors for it. They can both exist on the same motherboard, but you can't combine the two. You can have this RAID and that RAID, but you can't have those like that. M.2 NVMe RAID and SATA RAID, if that's a choice. Let's go to the next spec. Okay, now the fine print, we're on page 20 about RAID, talking about M.2 NVMe versus M.2 SATA. You can't mix them. To reiterate, you can't mix an M.2 NVMe with an M.2 SATA, and you cannot mix an M.2 NVMe with a plain SATA SSD. Those are like 3 different technologies. But the fine print down here, note number 1, supports on the 11th generation processor only, because you have to have PCI Express 4, which is 8 cores. Number 2, be sure to use an Intel SSD if you want to set up RAID configuration on this connector. So that's kind of a bummer. Now what I have to keep in mind is we don't have access to JBOD, and we have not. Although I have talked in terms of JBOD, but I haven't said it specifically. So I got to watch myself on that. Now this is in the appendix on page 47, configuring a RAID set. You can have a RAID 0, a RAID 1, a RAID 5, or a RAID 1.0 to reiterate. Okay, configure RAID set. RAID 0. You should have greater than 2 or equal to 2. And the number of drives is the size of the smallest drive. That's important to note, something that I forgot to mention previously. In other words, you don't want to have 1 terabyte and 2 terabyte, because then your RAID will be the size of the smallest drive. If you're going to use 2 terabyte and 2 terabyte, then you'll get your 4 terabyte just under that. Whereas if you use a 1 terabyte and a 2 terabyte, it becomes like less than a 2 terabyte, because it'll count it as 2 1 terabyte drives. Chain is only strong as the weakest link. I just wanted to point that out. And of course, this kind of RAID is a combination RAID. It's a hybrid BIOS RAID, of which this can do that, or it can do an operating system RAID, which is a function of the operating system. But this is a function of the BIOS. You don't have to have RAID, but if you choose to, you can. I want to go back before we go any further on the RAID issue, and let's look at those connectors. Now on page 4 of the motherboard layout, if you were to say you wanted to use those 3 drives, I would take that primary drive and leave that as the primary boot drive, M2A_CPU. If you chose to RAID, you could RAID those 2 drives. If they are PCI Express 4, keep in mind those can be 7,300 megabytes per drive. If you choose to RAID them, I'd RAID those 2, but I wouldn't RAID the 3 of them. But if you do choose to RAID the 3 of them, then more power to you. But I would say, based on the speed and for what you're doing, if you use the primary connector, keep your GPU at 16 lanes because it's about rendering, and then use your secondary drive, this drive, M2P_SB, which will be PCI Express 3. That's a 3,500 megabyte per second drive. So that could be a larger drive. That could be your render drive, your cache drive, whatever. And believe me, it'll be fast. Let's go take a look now at some information from Revit and see what they recommend. Now, Revit is an Autodesk product, and what I want to look at is not the minimum or value. I want to look at the performance, because remember, whatever specs we look at today, those are going to be minimum specs in the future. So you have to decide, do you want to build a 2-year machine or do you want to build a 4-year machine? Because there's a lot of technology in play right now. PCI Express 3, which is getting kind of long in the tooth, which we still have, PCI Express 4, or if you build up, because we've identified 4 levels of computers. The entry level, which it could be an 8-core, preferably 10, which is what you're looking at now. A secondary level, which we have identified with 16 cores, which would go up. And if you go to 16 cores, we need to change chipsets. Now, we can go Intel or we can go AMD, either way. If we go, say, Intel, we're talking a Z690, which we're going to be talking about some more in another video. A little premature because you can get the motherboard right now, some of them. Most of the motherboards are still not available. You can get the processor, most of them, but you can't get any RAM. So until you can get some RAM, it's kind of like SOL. And some of the motherboards support DDR4, some of them support DDR5. It's still up in the air. There's a lot of stuff with the Z690 that we're going to delve into for the simple reason of 3 things. Number 1, PCI Express 5, because of the RAM, and everything we look at in terms of rendering says nothing about the speed of RAM. It's about the quantity of the RAM. And on a high-end machine, they recommend 32 gigs. I'm saying 64 gigs. Okay, that's one issue. Issue number 2 is the PCI Express slots. Okay, you have a GPU. If you decide to upgrade the GPU, which is probably about a year off, for an RTX 4000 whatever, then that'll be PCI Express 5. Okay, that's something else you can't take advantage of. But the third thing and the greatest benefit of the Z690 is going to be for an M.2 NVMe drive that's PCI Express 5, which will be, instead of PCI Express 3 at 3,500 megabytes, or PCI Express 4, which is like what we have here, which is at a top 7,300 megabytes per drive, you'll be able to do 15,000 megabytes per drive. So all these things in play, you can do RAID, keep it simple. If you can have a faster single drive, that'd be the way to go. But it's going to be at a premium. So for where you want to be, if you want to build 16 cores right now, it's AMD. Whereas if you want to build 16 cores with Intel, you're going to have to wait a little bit until we can get this thing with RAM sorted out, which is going to be at a premium. And once you look at what's going on with the Z690, I think a lot of you may want to come back and take another look. And as we've identified, those 4 levels, the entry level, the secondary, the third, the tertiary, would be the TRX 40 Designaire. I think this is the best bang for the buck. No shared resources, all dedicated, but it's PCI Express 4. 2 16-lane slots and 2 8-lane slots, which is pretty good. Or if you want to go up one more, the 4th level, then you're looking at a workstation, which is the WRX80. So back on this, for where you want to be, based on a vision of the 3 Vision motherboards, which is, one was ITX, so we put that aside. For those that need that, okay. These other 2 are ATX, and the question is, do you want Thunderbolt 4 on the board, or do you want Thunderbolt 4 as an add-in card? Now, if Thunderbolt 4 is important, that you can add it later and you want to be able to do the three things that Thunderbolt does. Now remember, Thunderbolt 3 and Thunderbolt 4 do the same thing. There's only one benefit, and that's bidirectional bandwidth, because they both use 4 PCI Express lanes, 4 PCI Express 3.0 express lanes. 4 lanes, PCI Express 3. So what you get with PCI Express 4 is a vendor-specific connection, to reiterate on Gigabyte, a 5-pin and a 3-pin connector. And of the three things that Thunderbolt does, number 1, power delivery, which we're not a fan of. Number 2, data delivery, which I think is where it's at. But number 3, if you want to be able to route video, and I think we're going to have to do a separate video about how the plumbing on that works. Thunderbolt does not have video in it. You have to route video into Thunderbolt to get video out of Thunderbolt. So with the video on board, I believe you'll get 4K. Let's take a look. Okay, I wanted to take a quick look at the Vision D motherboard, and it says right here specifically, you can connect a drawing tablet or a standard DisplayPort Thunderbolt monitor to this connector with an adapter. The VisionLink Thunderbolt connector supports a resolution of 4K 60 when a graphics card is connected to the DisplayPort input for the VisionLink Thunderbolt connector to output. I just wanted to verify that. A lot of times the boards that have Thunderbolt 4 built, or excuse me, the boards that have Thunderbolt period built onto them, out of the port with inboard video, you'll get 4K 30. If you want 4K 60, then you've got to route that through an external video card. Okay, you're going to have an external video card. That's a given. But I just wanted to double check that. That's what I was looking at. Looking at a big difference in the Vision D versus the Vision G. Let's go back. But to reiterate, even though this video is about the Gigabyte Z590 Vision D, I think the board that you're going to be probably having a preference with will be the Z590 Vision G. And that's a difference of $370 versus $250. I want to go back over to the specs I didn't get into a while ago with Autodesk. If you notice, a 64-bit operating system of Windows, right here on the CPU type, single or multi-core. And it talks about an Intel Xeon or an AMD equivalent with SSE technology. The product uses multiple cores for many tasks. What I would want to do is investigate that a little bit further, because if we're using a Ryzen, an AMD Ryzen like the 5950, which will get you 16 cores, I believe it'll meet that spec. Because if you were to use an Intel Xeon, then we have to look at a different chipset, a chipset that would be based on a workstation. So that's a completely different setup, completely different chipset. You're looking at something for a consumer chipset that's a little bit more feature friendly and affordable. So if we're looking at the Vision I think will get you what you need, but again, it's how many cores do you want? You want to look at 8 or 10 cores, or do you want to go to 16 cores? 16 cores now or 16 cores later? So there's a lot more information that we need to talk about that I want to help you, because I think this is absolutely fascinating. I love doing the what ifs, because we go this way for one thing, we go that way for another, and one thing changes everything. Let's go back. Now they talk about here 32 gigs of RAM, and I would want to be able to start with probably 64 gigs. On that board you're going to have dual channels, so if you've got 2 slots, you could do say 16 and 16. There's your 32 gigs, and if you decided to go to 64 later, 2 more slots, you can do 2 more 16 gig sticks. You got your 64. So I like room to move. I like room to upgrade, because again, I think if you're building an 8 or 10 core machine, that's about a 2-year machine. Whereas if you're looking like building a 16 core machine, I think you're going to have something more like a 3 or 4 year machine. That's just my opinion, my take on where all this sits. I always said if I ever learned enough to fill a thimble, I'm going to use that to try to help people to build a computer that they need to build. It's not just what you need today, it's what you're going to need tomorrow. And you want to get value, the best bang for the buck. Let's go back. Now, another aspect that we have not crossed yet that we need to start addressing, and this is a good example when we get into the display, because this involves also the monitor. Now, the resolution they give is 1920 to 1200, which is beyond 1080 resolution with true color. And true color, that's you're good to go with your display adapter. However, your monitor, because it mentions that spec, what my suggestion would be to looking at a monitor, which is not a part of this, but I'll put a link up in the description. Something like an Asus ProArt, you can start with something that does that for an entry-level color correction. And I would say an Asus ProArt, look at Asus ProArt Rec 709 for color grading. That gets you the resolution, that gets you the color depth you need. But if you're looking at 4K, something along those same lines from ASUS will fit that for a 4K monitor. But we need to get more into that, but let's get back to this. And of course, your video adapter. This does not talk about only 4 gigs of memory. It doesn't mention CUDA cores. Some of the other specs do. One of the specs even addresses an SSD, and it talks about a 10,000 RPM drive, which is on here. Let's go back and take a look at that, which I don't think anybody uses 10,000 RPM drives anymore, or a solid state drive. Okay, well, instead of a solid state drive, we'd be using an M.2. There's another set of specs with more specificity, and again, I've got about 12 applications. I'll have the links in the description so you guys can take a look at them and compare, because you want something that's going to be as well-rounded as possible. And I'll also include a link in the description on Revit about changing the hardware acceleration setting. That's something you need to turn on to take advantage of your GPU. Because I like to follow the Adobe After Effects multi-frame rendering CPU optimization formula. It's a nice package that looks at CPU cores times 4 equals RAM, and then CPU core count equals video RAM. And you put those numbers together, it's a real nice place to be for a system. Now, how does it relate to this? I think it's a better set of specs that gets you a better machine that's going to be something you're going to use for a little bit longer than what these will, because we have to extrapolate. It's the same for some of the video applications we use. It's again, I don't use Adobe software, but I like that formula. It's the best formula we've had. Let's go back. For determining specs on a build. Now, they cannot test all GPUs, but going forward, I like to interject anybody that's going to be buying, whether it's a desktop or a laptop for content creation. My suggestion, based on what we've done research-wise, is an RTX 3070 or above, nothing less. Now, you've got an RTX 3060, you're fine. You've got it, it's good to go. 12 gigs of RAM, it's going to be good. And with 12 gigs of video RAM on that card, 10 cores would be all right. But that's PCI Express 3. For PCI Express 4, you're looking at 8 cores. So I would want to up the core count. I would... And we've talked to some other subscribers who are doing some of the things like you want to do, where they don't need a lot of core count, but they need a higher video RAM count, more GPU processing power. And we've got some subscribers that are looking at like an A5000, and they're going to put that on something like a like this machine that we reference, which is the Gigabyte TRX40 Designaire, because of dedicated resources. It's great for one GPU. With all the other stuff we can do, it's bang for the buck. I think this could end up being a 7 to 10 year machine. Not quite the specs of what the workstation has, but if you need the workstation, you know, that's another video that we're going to talk some more about later. But back to these specs. To get you where you want to go, and back to your original question, which one of these three? I think your best bet with these three is not the Vision D, but the Vision G, based on the price and based on the features. I think for $250, that'll do you. You can get your DDR4 RAM. In fact, let's add that to the chart, and let's go look at a CPU. And remember, we're looking at, I'll change the core count right here at the top. This is a nice place to do your what ifs. We'll change that to 10 cores, but we're going to have to drop it down to 8 cores. So we're looking at an i9 11900, and yes, it has the graphics on board. But the 8 cores gets us PCI Express 4. Whereas if we go 10 cores, we're PCI Express 3. We'll add that to the list. That gives us the 2 primary components. Yes, you're going to need a cooler. Let's look at memory. The sky is wide open on that. Based on compatibility for what the motherboard will support, let's go back and look at the specification. It'll do DDR4 3200. So my advice would be either DDR4 3200 or DDR4 3600. I believe it's in the list. Yeah, either one of those. And I would look through a list like this and then do your what ifs and compare, see what you find. Because right now, if you'll notice, there's 3,460 compatible products. So again, I'd go down through this list and I would look at, if I'm going to do 32 gigs, then show me 2 16 gig sticks, which would be 2 16 gig sticks. And that gives me 515 products. What about the speed? Let's scroll that over to DDR4 3200, and let's pull that down to DDR4 3600 and see what kind of parameters we're looking at. Or even 3666 right there. DDR4 3200 to DDR4 3600. And that gives us a list of 253 products. So you can see how we can bring that down pretty quick. Then what we can look at is either by price over here on the far right, or we can select by rating. And if we're going by price, Silicon Power, I don't know that brand. I'm not sure what they use. I would go something like G-Skill if you want the performance stuff, or I would use Corsair Vengeance. If you went with G-Skill, then let's select by G-Skill, and we come up with 69 compatible products. And depending on whether height is a requirement or a problem, for 32 gigs, $110 right around. Now another application I want to show you real quick. The list I pulled together was from G2 about the top 10 Revit alternatives and competitors. I'll have that link in the video for the description. Blender specs, pretty easy, 32 gigs of RAM, so 32 gigs is a safe place to be, but to reiterate, I'd have the option to go to 64, and that's what they call optimal right now. And your graphics card with 12 gigs of video RAM, and that's what you have, so you're good to go. Now, all they say is OpenGL. They don't specify CUDA cores, but you have CUDA cores, so I think you're going to be in a good spot. So we'll also have a link up to the Lumion specs on their high-end requirements. They even get into specifying a power supply, which is unusual. And they also talk about the drive being either a SATA 3 SSD or an NVMe M.2. And of course, the NVMe M.2 is what we recommend. Now, the resolution they recommend is 1920 by 1080, and they also recommend a graphics card with 11 gigs or more. You're at 12 gigs, so you're good. But they recommend an RTX 3080, so I wouldn't worry too much about that, but you're in a good ballpark. Now, they recommend for memory 64 gigs of RAM. So again, each one of these is unique depending on the details you go. If you need some more help, please let us know. We're here. I hope this helps. I want to thank you guys for watching. My name's Gil Boyd. This is BuildOrBuy. Love you guys. See you in the next video. We're out.